Of course, you can say that the most important part is, of course, the the GNS file. So let me try to see if I can find the location in where we're logging, the logging location, logging np, and then this is a subfolder. And as you can see here, I actually have already started the second file here. This is a custom file, the general file and the survey file. General file can be opened using Notepad. There's a lot of information regarding header, and then further down here, we have the actual data. The first part here is identical to what we are logging in Navipac or the Navipac format. That's basically this part here. And then the second part is the raw data. R44 means raw data from ID 44. You might remember that this was GPS1, NMEA, timing, etc. This is the GTA string itself. I'm not going to go into detail about the format, just refer to the, let me see if I can find it. The documentation side. Here it is. Software. Here on the Navipac. You can even go to Navipac 4 if you want to. And then here is the Navipac 4 logging utility. This document describes everything there is to know about the different log data formats. The general format here. A lot of details, and I don't think it is required from normal users to be experts. But this is where you find the information about the format. As you can see, it's quite a comprehensive document. Right. Let's continue with the enhancement display. There's a lot of interesting stuff still waiting for us. You see, I'm still logging data, which is fine. If I select my vessel here, of course, if I want to stop logging, I don't want to do that now, but if I want to, then I press the stop button here. But right now, I would like to create a data view. This is a data view, and it's even not just a data view, this is a dedicated runline-based data view. Predefined. I can right-click in this data view here, and then add and remove the different items that are available. But all these items are related to the relationship between the vessel and the runline that we have chosen right now. There's a lot of possibilities. I'm not going to go into details because I'd like to talk about data views in more general terms. But of course, you can say, I don't want to see the header because it's already up here, so I disable the header. I might want to look at the, here I have estimated travel time. or ETA, end of line. That is interesting. As a matter of fact, here it is. Today at 13:32. That's a little bit late because we're already going to stop at 1300 hours. But you can also change the sequence just by dragging these up and down, as you can see here. And so there's really a lot of possibilities with this. But I would prefer to show you a dedicated data view also. So here, let's imagine captain wants to see the water depth displayed on the HazMat display. So we create a data view here, view, new data view, like this. Now, you need to, and this is why I'm saying that you only have limited amount of possibilities in the runline-based data views. Here, you can choose from a long list of what we call live data. Live data is a combination of different data that comes from different sources. Majority comes from Navipac, but some of it is also created in the HazMat display. But one of the things I would like to show now, of course, is, and this was what I initially said, that we're going to show the water depth, would be the data coming from the 210 kilohertz here. This is this one here, 210 kilohertz. That's what I want to see. I'll just say okay to that. So now here it is. I got a data view that shows the water depth. At least that's what we thought until we showed this to the captain, who wasn't too pleased because he said, this is not the water depth. This is the distance from the transducer to the seabed. But the transducer is 4 meters and 55 centimeters in the water, he says. 4 meters and 55 meters in the water. So I want to see the water depth, but I also want to see the depth below hull. And then he tells us that the distance from the transducer down, or maybe we know that because we're the surveyors, is 3 meters and 28. I'll remember these numbers. You don't have to do that. So we need to show that to the captain in the HazMat display. In order to do that, we need to create what we call a, here under Tools, Live Data, Custom Live Data. Custom Live Data, as the name indicates, allows us to customize some live data. If we go to the bottom here, there's a list of tools here. You can see there's a lot of arithmetic functionalities here, but also a lot of items related to what we have in a HazMat display at present. It's not so user-friendly, meaning that you cannot filter or anything like that. You have to manually find the items, and there's a little bit strange way. This is the vessel down here. Yeah, well, basically this is items related to the project, HazMat project. And here we have the vessel. And basically I need to find the 210 kilohertz somewhere. If I can find it, here it is, 210 kilohertz. So if I click on it, then it will appear in the expression immediately. And I get a value, and that was the value that was valid at the time I did the click on it. So actually, the water depth, there was a distance of 4 meters and 55 between the transducer and the surface, water surface. So that's what we'll add to our reading. So we'll call this water depth. We need to give it a name as well. So now we have created a custom live data set like this. Nothing is, of course, happening, at least not in our displays, but in the project tree, we have now got an entry called live data, water depth here. And here you can see the expression. Once that is there, I can add it to my data view down here. I right click on the data view window and choose add remove live data. And then water, there's only one water depth here. Okay, so this is the water depth. But we also need the depth below hull. That we can establish that by choosing tools, live data, custom live data once again. And then this time, once again, we find the 210 kilohertz. And that was the reason why I wanted you to type in the name of this. Yes, in other sequence is different. That is really strange, but that's how it is. 210 kilohertz. And this time I must subtract 3 meters and 28 depth below hull, like this. And okay to that. Depth below hull. And of course, then I can add that here, add remove live data. And then type in depth below hull, like this. So now that is also shown. And of course, I want to take it to 10 kilohertz down here. And then this is a view, the data view here. So I will able to find it under my views here. Map view, two left-right indicators. There's a run line view here, and then a data view. And that's the one I have here, subdivided into the three tiles that I have here. Water depth. I can change the name. I'm not interested in that it's a double. I want to change the units, to customize the units, because I want to be able to see that the unit actually. I need to customize it. And then the abbreviation meters. And then I choose only to have one decimal, because I don't think the accuracy allows for more than one decimal. I need to do exactly the same for the depth below hull. Remove the double. Unit customized. Abbreviation meters. And then one decimal. For the 210 kilohertz, I just want to change the 22 in brackets. I'll show you what 22 is actually. And then further down, units. I need to change it, even though meters is correct. But I only want to have one decimal here. number of decimals 1, like this. So now I think the captain is reasonably happy. And as a matter of fact, I could also show this as a graphics view if I wanted to do that. Here, right-click New Graph View, and then depth below hull, like this, and then it looks like this. But this is simulated data, so not so interesting, as you can imagine. But in a real scenario, you could probably see how things are developing. If you're getting too close to the seabed, then of course that would be something that would be flagged in a graph view like this one here. And of course, a graph view here, actually in the view over here, you can add live data. So I could also show the water depth if I wanted to do that. It's not so interesting, I think. There it is. There's also always a constant difference between the two, as you can imagine. 7 meters and 83 centimeters, as a matter of fact. But anyway, this is, and you can also see that there's a lot of possibilities here. This is quite simple. The customized data view that we are creating here. Tomorrow I'll show you a more complicated one, but that's a little bit premature right now. I'll close the graph view. I don't want to see that again. One thing that we haven't talked about is waypoints. Waypoints can be created by or from the Create toolbar that we also enabled yesterday. This is the Create toolbar. If you haven't got it, then choose View Toolbars, the Create toolbar. This is the waypoint icon. So, yeah, well, what can I say? This is a little bit. I haven't seen this before. I have to be honest with you and say that this is new functionality. Let's see how it works. The target position is really this position that I have here. Or we also sometimes call it the camera position. This is the center of the map view window. Let me just try again. New waypoint, target position. If I say OK, then I get a waypoint right there. But if I want to create a new one, I want to create it at easting north. Come on. Don't tell me I can't do that on the cursor. This is really crazy.
Lars, I see you have two create waypoint icons on top of the screen.
Yeah, I know. What do you... Yes, you're right. So this one is really strange. But it's a new one, that one there. So this one, new waypoint. Yeah. Cursor created, that's what it should say. But it doesn't. But anyway, this is waypoint number 2. Let's see what happened. Thank you very much for that, Kim. Let's see what happened. I got now in the project tree waypoints here. I got a waypoint file. In that waypoint file, I have two waypoints. Waypoint 1 that was created here at the target location, and waypoint 2 that was created from my cursor location. Let me just create another one so you can see how it's working. This is the waypoint 1, 2, 3. An alternative to creating waypoints like this could be to actually just bring in a waypoint from a file. Either Navipac waypoints. There is a simple waypoint file here called Aarhus Transit or Aarhus.wpt. Aarhus, well, this is the location where we are right now, the hometown of Iva. I can just drag and drop that to the map view window. And then, as you can see here, we've got some waypoints. Buoy 1, 2, 3, 4, 5. Let's have a look at the file itself, WPT file, and open in Notepad. You can see that it's really a very, very simple format. Name, easting, northing, and height. I could also have opened by saying file, import file to project, and then let me see if I can find it at all. WPT, here it is. Different formats. They're all described in the document I showed you earlier, the one that was underneath the runline format. So you can see my cursor is still ready to create waypoints. So I'll create another waypoint now and see. Now it's called waypoint 6, which is a little bit confusing. I thought it would be called waypoint 4. But the reason for that is that you can see that here. I have two waypoint files or waypoint collections. The first one here, waypoints 1, is the one that I've created manually. Second one is the one that I dragged and dropped. But notice that it is written in bold. The second one, it is the active waypoint collection or file. If I right-click on waypoint 1 here and choose Set as Active File, then that would be now shown with bold. And if I create a new waypoint here, then that would be waypoint 4, because that's the next number in this waypoint file. So waypoint 4, the waypoint 6, if I want to move that to waypoint 1, I can just drag and drop it there. And then, as you can see here, even change the sequence. So then now that is waypoint 5. And I can change the name of it to waypoint, or sorry, waypoint 6, waypoint 5 if I want to do that. Yeah. Escape on the keyboard, then I'm not creating any more waypoints. The waypoints can be edited. This was waypoint 2. Let me see where I have. Let's have a look at waypoint number 2. A waypoint, if you right click on it, you have the dedicated menu. One of them, one of the items here is edit. If you do that, then you see this circle around the waypoint with a yellow square. If you grab it by the yellow square, you can move it around. Move it to a new location. You can also rotate it, even though that doesn't make much sense because right now we don't have anything to associate the waypoint with other than just this point. But if I right click on the waypoint again, then I can attach a 2D shape. It could be one of the ones we created yesterday, the Svanen shapefile. And now, of course, I can rotate it as you see here. There's a lot of possibilities with waypoints. You can also, on the waypoint, and I find this to be very elegant, actually. The position here, if I press the browse button, the position is all 3 components, easting, northing, and height. If I browse, then I can link the waypoint position to an item that I have in my headless display as part of the live data. It has to be an object. It has to be something that has both easting, northing, and height. But I can also do something else. I can say the water depth. I want to relate the depth to something that I have in my headless display. And of course, the relevant things to do would be to say, okay, I want to relate this to the water depth. Yeah, custom live data that we have created. If I say okay to that, I can't see anything happening. You can see that it's related to the water depth. But if I go into 3D, you can see that it moves up and down. But this one is at the location or the height where we have, basically from the 210 kilohertz. So let me see. I'm not sure that it really works, but in theory, I should be able to link the easting to the vessel position, easting. Where is that easting? Here. This is the vessel. No, not that one. This one here. Vessel position. I don't know where it is right now, but here it is. And then I can take a northing as well, browse, and link that to the northing position of the vessel. Position northing here. Okay, so that's, and now, of course, I have, this is now underneath the vessel, and maybe we can even take the heading and link that to the gyro of the vessel. See, now this is elegant, I think. Even though, of course, it doesn't make any sense to have this shape used down here, but basically, this is following the vessel and is showing the location. a little bit confusing that the RV is underneath, but that's just a principle. But this is one of the things that this could be used for. And of course, I would probably go for another type of a shape, a diver or whatever, something that tells me that this is the water depth right now. But these are among the possibilities you have, and that is certainly, I find this very elegant to be able to do something like this. Live data is a very powerful set of functionalities, I think. But anyway, let's move on to something entirely different. The Datamon. Because we are now ready to continue with the preparation for the exercise. A lot of what we are doing today is related to Datamon. Well, I'm assuming that you guys know nothing about Datamon. There are certainly some of you that don't. So I'll more or less start from scratch and explain everything there is to know about Datamon. Datamon.
Sorry, excuse me. My Datamon is blank. Is it okay?
Yeah, it's okay. No problem. It's because you don't have any project, but you will get that shortly. Datamon consists of two different windows, the actual Datamon window and the configuration window. So if you right-click in the caption, then you can open the configuration or visualize configuration. Visualize is more correct. This is a little bit strange. You see, I can't see it. Maybe I can open my configuration here and then choose the one that I created last. Yeah, there you go. If I right-click here and choose Visualize Configuration, then I get the configuration window here, and it's as Samuel was saying, this is my last configuration, the one I created a couple of weeks ago. So I want to start from scratch. I do that by saying from here, File, New, and now it is empty, as you can see. Datamon, the configuration has a series of tools that you see here to the left. There's a canvas here where we are defining our configuration, and to the right we have some properties. And that's basically it. And then, of course, also the main Datamon window. But we want to start by connecting to Navipac here, Navipac IO. Drag and drop that up here to the far left. Navipac IO, you should always, there are some triangles here. You should always be aware of those triangles. This one is red. That's not a good sign. That tells us that we are not connected to Navipac. So how do we change that? We simply change the property, connect to Navipac to true. And now I have a green triangle. Now, if I right click, then I see all the sensors that I have defined in Navipac. The one I'm interested in is the one here at the bottom. So the Seabird 49 CCD. So you can say that originally Datamon was intended to be used to visualize alphanumerically the different items that we have defined in our Navipac configuration. And we can still do that, but we can do a lot more than that, as you will see. I want to display my three channels, or the values of my three channels, alphanumerically and graphically. This is my the first thing I want to do. So for that, I will open the display tools here. And then I will take the ASCII window and drag and drop that here. When I have a display, I also have an extra window that I need to dock on the actual Datamon here. So I'm docking it, as you can see. Once again, I grab it by the caption and then move it to one of these squares, the one at the top here. ASCII window. The ASCII window, if I select it here, has properties. One of the properties is inputs. Here under my cursor, I change the number of inputs to 3. So now I have 3 inputs. And I can now connect my Seabird data one by one to the ASCII window. Look at what happens if I do it. This is the connectivity. Here is the temperature, and here's the depth. Remember that we were receiving pressure from the Seabird, and that Navipac was converting the pressure into depth. I still owe to show you how that can be handled in Navipac, because we didn't talk about it. My mistake. Pressure to depth parameters from Navipac Online. Go to Options, Depth Calculation Parameters here. So the values that we're going to use for this is the simplified Sorensen-Pfaffenhoff formula, where we need water density, the pressure at surface that is subtracted from our pressure readings, and then the gravity. That is all we need to convert pressure into depth. You can do it in a more sophisticated way, which we will come back to in the post-processing. But here we'll just use these 3 parameters. And I would like you to use the same parameters as I am. I'm not a control freak, but this will give us the same calculations or identical calculations, which is certainly a good thing. I'll give you these parameters on the chat. So please change your parameters so that they're matching mine. In particular, the gravity, because the others are default. The gravity is one that I have entered manually. Okay to that. Back to Datamon. The graph window said we were going to look at data alphanumerically and graphically. So I'll take the graph window and drag and drop that here. This is a display window. Therefore, I need to take the window and dock it. It is very important that you dock these windows. Otherwise, you're going to lose trace of what you have done and what you are doing. So please dock the windows. I took the graph window next to the ASCII window just to indicate that they belong together. For the graph window, the property lines is the same as input for the ASCII window, 3 lines. And now I'll take it from the seabird here and connect. Notice that if I click on one of these triangles, I get a connection line to the cursor, and also green circles around items that this particular one could be connected to here. So now I have connectivity, temperature, and depth. What we can say about it is that it is certainly not varying a lot. Rather, on the contrary, it is constant. But that's okay. That actually makes our lives a lot easier. So this is the original purpose of Datamon. Very, very, at least very reasonably simple, but also I think a nice solution with these connection lines, etc. I want to save my configuration now. File, save as, and then I will place it in my project folder. Structure here under Datamon, the Datamon folder, and then give it a name. On off _4 like this. Save. One of the things I need from you guys is your Datamon configuration. But please be aware that the Datamon configuration consists of 3 files. Let me show you. Here, these 3 files. And I need all 3 files, otherwise I can't evaluate your exercise. Now it's saved, and I need to do something entirely different because I'm now really interested in looking at the raw data from the seabird. See, the seabird is coming in on the RV on COM12. And that means that because of the port sharing settings that we have defined, Navipac will send this data out on ATTU port 16012. Well, this data is actually not going to be used in Naviscan, but we can use it in Datamon. I'll show you how. ATTU, the ATTU format is using the UDP IP protocol. So what we need to do now here is to create a UDP IP port simply by dragging and dropping that to the Datamon configuration here. This is a UDP port. In the properties, you see that we have local IP and port and remote IP and port. Generally speaking, you can say that local is incoming data, remote is outgoing data. And of course, this is incoming data. We are interested in reading data from port 16012 that Navipac is outputting. Originally designed to be read by Naviscan, but we can also use it here. As you can see, I have a green light telling me that there's data. The local IP 0000 really means that we are using, we're not filtering on the IP address. That means accept everything. And that is, of course, fine, but we can also just type in the correct IP address, which is 127.0.0.1, like this here. So now data is coming in. But how does the data look? We can take the ASCII window once again, display. And once again, I need to place that here. I'll just make that fill out the rest of what we have here. Now I can connect this one to here, and now you can see the raw data. This is the raw data coming in. Coming from Navipac, but it could come from an external source. This is how you should look at it. This could be an instrument that's outputting data. We want to interface that instrument into Datamon and manipulate it in here and do something that we might not be able to do in Navipac, for instance. This is one way of looking at it. You can also say that we can use this functionality, port sharing, to actually distribute data to other locations. And that's also what we're doing here. But this is a text string, so I can't really use it as it is. I need to convert it here under converter text. There is something called string splitter, this one here. I will take the string splitter and then I will delete the connection to the ASCII window. You just highlight the connection line and press delete on the keyboard. And then you let the data go through the string splitter. Let's have a look at the properties of the string splitter. We want to have 5 outputs. Remember, we have 5 set of parameters. So 5 outputs. What we can do to make our lives easier is we can change the labels on the string splitter because we know what they are. The first one is the temperature. If you're in doubt, you can look at under my cursor here. You can see that this is where they are on the Seabird instrument. Second one is then conductivity. Third one is pressure. Then we have salinity. And finally, number 5 is sound velocity, like this. So on the ASCII window, we can say that we have 5 inputs instead of just 1. And then we can connect these one by one to the ASCII window, and now you can see here. So now we even have more information available than we do in Navipac, at least different information. Items that we don't have available in Navipac. At the end of the day, I want you to create what we call a user-defined input in Navipac. But this user-defined input comes from Datamon. So that means that we are going to create an instrument in Datamon with 3 channels that we can read in Navipac. Now let's see, we need to have 3 pieces of information. One of the information that we need is one that we are creating right now. This is calculating sound velocity. I know we have sound velocity here, but we're going to calculate sound velocity based on the information we have here. We are using the so-called Medwind formula. This is a simplified sound velocity formula. Let me see where it is. Not that one here. I don't know if this one. Yeah, here it is. This is the one. Okay, I'll stop sharing and resharing. Hopefully this is better for Raymond now. And I saw that you were reconnecting. I don't know if that helped. I hope it's better now, and I hope everybody can see my screen.
I can see it now.
Oh, that's good. But this happens sometimes. I don't know why. But anyway, these are different formulas. Chen-Millero formula is the full UNESCO formula. But down here we have the simple Medwind formula. This is the one we're going to use. As you can see here, we need temperature, we need salinity, and we need depth. This is exactly what we already have in Datamon. So we need to introduce this formula here. I'll take now on the converter number, we have something that is called a function. Right, the function here, by default, it has 3 inputs. This is nice because that's exactly what we need. So we're just saying that A here is temperature. We take that from here. B is then salinity. The only location that is available is here. And then finally, water depth is taken from here. Now we must enter the function. Let me see if I can zoom in. Yeah, and I'm zooming in a little bit. It's probably a little bit easier for you to see now. And I will enter the values here. And notice that you have to use the convention here. You cannot just say 4.6a. You have to say 4.6 multiplied by a. And here, a square, sorry, this was not what I wanted to do, multiplied by a squared like this. These spaces that I'm introducing, you don't really need. I'm just entering them to make it a little bit easier for you guys to read. .34 minus 0.01 multiplied by a multiplied by, in bracket, b minus 35 plus multiplied by c, like this. I hope this is correct. Let me. It is not easy. Put it on the chat. Hope it's correct. It's on the chat now. Okay, so that. And I can then add another input in this ASCII window here. I can also, no, I want to create another ASCII window. Display ASCII window here somewhere. And then place that over here. I know what it should be, and this is correct. So basically, I can give you the function on the chat as well directly. It's not so important that you enter the function correctly. It's more the principles of what it is that we're seeing. So you also have to bear with me because I have to progress a little bit faster than I normally would, because this is an exercise, and basically you guys should be able to do it with a little bit of help yourself. So what I need to do now is to create an output. The output is once again a UDP port. So I'm starting here a little bit backwards. The UDP port, I move it over here to the bottom. And I'm looking at the exercise notes because I want to make sure that I'm not saying something to you that is not correct. Yeah, the output. See, this is an output. Remember, output was remote IP. So I'll simply type in 127.0.0.1, and then the port number is, as far as I remember, it doesn't really matter, but I have written 5030 in the exercise notes. So we are now ready to output items. Right now we don't have anything to output, but we want to create a user-defined data acquisition instrument. And you know that a data acquisition instrument needs to have a string prefix and 3 channels. So this time we'll go the opposite way. Instead of splitting a string, we will merge a string. You find that under converter text, and then this time choose string merger. Like this, a string merger that doesn't have any input, but it needs to have 3 inputs. And these 3 inputs are, of course, the 3 channels. So I change the property, the number of inputs to 3, and then I remove the 3 in brackets. And the latter is important because if you don't remove it, you'll get a lot of error messages saying that we're missing something somewhere here. We can already by now say that the Medwin calculation that we have done is the first input. This is going into column index 0 here. So now we have data, and you can see that I can actually connect to the UDP port. So actually, it is already by now outputting this data. The string merger, notice that it is comma separated. The second item that I'd like you to use is salinity. We move salinity down to column 1. Column 2 will wait a little bit with column 2. But the string prefix, this is one of the good things here. This is very easy. You just type it in manually in the properties of the string merger here. Start by saying $on off 4, comma. It's very important to remember the comma here because otherwise they're not separated. I typed in $on off 4. Give you this on the chat now. Like this. So now the last item here is, well, you could say a little bit of a secret that I'm going to reveal to you now, of course. I'm not here to keep secrets from you, but we are going to calculate the gravity at our current location. Let me just show you how this can be done. From the documentation side, here we have related topics, and then we have something called gravity calculator. It's just a shortcut to something that's got really nothing to do with diver, but this is a calculator that is able to calculate gravity at any given location. We are at approximately 56 degrees, and our height is 0 because we are at the water level. The height unit is meters, and this is then the gravity. The point is that we are not at latitude 56 exactly. If you want to know the exact position, currently you can go to Navipac online. There's something here called Calculate. And then you can use coordinate conversion. This functionality will give you, this is actually our current location. If you change, right-click on the label and change that to decimal degrees, then this is actually where we are right now. It's just a And a nice way of getting our current position with a number of decimals. There you go. 9.81605. This is our current gravity. But the point is, how do we calculate that? If you go down a little bit further here, you actually see it is a reasonably simple formula. Actually, this is the international gravity formula. That will determine the gravity based on latitude and free air correction. This is the IGF formula itself, and this is the latitude in radians. And the good news for you guys is that Datamon calculates in radians, or rather, it will give you latitudes in radians. So here, the free air correction, the only unknown here is the height, and then you add those two together. But you need to establish this function here and that function. You can also combine them into one function in order to calculate the gravity. Let's see how we can do that. At least I will show you some of it in Datamon. Latitude and height would be the input to our new function. So convert a number, I will add a function here. This function has two inputs, like this. A is latitude and B is height. So where do we get that from? We get it from Navipac connection here. Right click, and then you can choose your vessel name here. This is the vessel. And then you can simply take the latitude in here and the height. And now the key, of course, is to define this function. I'm sure you guys can figure out how to do it. Otherwise, I will send you on the chat a function that works in 1.5 hours, 2 hours perhaps. So give you time to play a little bit with it. For now, I will just use A and B just so that I get a number out of it. This is not correct, of course. You have to get the right function. But for now, it is fine. So that means that we are almost there. I can connect this function output to column index 2, which is basically the third column. So the only thing, if you have followed what I have done now, the only thing you need to do is to define the function. I will, however, save my configuration. I might even have two inputs on my ASCII window here. Now you can see this is the gravity, which is, of course, totally wrong. Midrin units meters per second. And then this one here is gravity. And the unit here is meters per second squared. And it's a good idea to have 5 decimals so that it looks something like this. But it's wrong, of course. It should be 9 point something. Yeah, I'll save. And then I will go to Navipac, because the point is I need to create a use-defined input that can understand my output from Datamon. So there are many, you could say, sub-purposes of this exercise. One of them is, how do I create a use-defined input? You do that from data acquisition here, and it is on the vessel object. Right-click, add instrument, and then this is a user-defined. I can just type in user here. Defined input, this one here, use-defined input number 1. Okay, so that, and then I get my I/O selector, UDP port, local IP 5030, like this. For the first time, I can connect, and you can see data is coming in. This is, of course, also working here the same way it was working in Navipac 3. Now I'm getting this data comes from Datamon. My string prefix, Medwin, salinity, and gravity. So, okay, so that looks fine. I need to define my properties here. I can start by calling this on/off underscore DAQ, data acquisition. IO mode, of course, is on because the data exists. In reality, a UDP port is also correct. Everything is comma separated, item separator, comma. And then the 3 channels. The first channel here is Medwin, meters per second. That is sound velocity. So where do I read it? Read item at field. Let's go back to Datamon and have a look. The string merger here in Navipac, this one here, the string prefix is field 0. Next one is field 1. This is field 2, and then the last one, the gravity, is field 3. This is in Navipac. That means that the Medwin will be read at field 1. The rest here doesn't really matter, but for channel 2, you need to specify salinity, read item at field 2, and then finally gravity, read item at field 3. And then at the bottom here, string prefix, dollar on off underscore 4, like this. I don't know why there's an exclamation mark there. But anyway, this is how it is, and there's not a lot to complete, as a matter of fact, I would say. The only thing you need to do is to complete the data acquisition instrument, but also to enter the formula for the gravity correctly. Let's have a look here. You can see here it says these are the exercise notes. Today's exercise is divided in two, the Datamon part and the Navipac part. In the Datamon configuration, you must create a function that can calculate the gravity at the current location using latitude and height from the vessel object as input. The formula is shown in the next slide based on the International Gravity Formula. I'd like you to check your results using the local gravity calculator and use 5 decimals in the comparison. I've shown you how you can check it, but of course, one thing I didn't show you was that actually the height coming from Navipac is actually 20 meters. So this is your result, as a matter of fact. But it is important to use 5 decimals in the comparison. What you should then do is to create an output from Datamon by creating a text merger with 3 inputs. 1 is instrument. Input 2 is the temperature. That is not correct. This is actually the salinity. And input 3 is the gravity that we have calculated. On the output side, you should add a string prefix as the first part that I've shown you. And then remember to use comma separated also between the string prefix and the remaining part, as I have also shown you. Then you should add a UDP port with the following properties: remote IP 127.0.0.1 and remote port 5030, because this is an output. And then finally, you connect the text merger output to the UDP port input. The next thing is to go to Navipac and create a user-defined input that can read and understand the output from Datamon. It's a good idea to go online and see if it actually works, the raw data window and or Datamon. So one thing that is important here is that you should remember to save Datamon before you restart Navipac, because otherwise you'll just use your your Datamon configuration. You don't want that to happen. Yeah, and I've this is a data exercise where I have actually taken a screenshot of this particular page that I showed you in the gravity calculator, and this is basically what you have here. One thing I want to tell you is it's this here, the convention. How do I write sine squared to the latitude? Well, you do that by writing, let me see, the best way of showing that would be in the function. And this is not the correct function, but basically this is how you do it. Sine a squared instead of sine squared a, that is the function or the convention or terminology convention that they're using in the gravity calculator page. So this is how you should do it. Sine a squared. But remember, this is not the right formula. I remember that there was a question at the beginning of the day. I can't remember if I have answered it. Probably not. Yeah, that was from Samuel. The default folder for the Navipac configuration. There is no default folder. I mean, I'm always saying that people can place their Navipac configurations wherever they want to do it. To be honest with you, I think that Navipac is initially suggesting somewhere in the Navipac configuration setup or something like that. I'm sure about it. But as a matter of principle, and this is something that I have fought with the software guys to make them understand, is that I don't want to mix data and software. So logging in the, I can't remember where it is. Is it in the log folder? That's the default logging folder when you first open the log data window. I think that is really a misunderstanding. To me, the Navipac folder contains software information. There could be some run lines, etc., help information that is available there, but I would never, ever put data there. I would place my data in a separate folder, the way we're doing it here, this project folder here, with some, basically dedicated folders, meaningful names, etc. Those of you that know your Navipac 3 might ask a question. I'll try to. You don't have to do it. I'll just do it. But before I do it, I'll save my datamon configuration, and also to be absolutely sure, I'll save my HealthNet display and even stop logging at this stage. And then I want to stop. I will exit online. Because of the fact that I want to try to use the project manager here. The project manager, some of you may be aware of it. It is really, I don't have any archive folders here, but it works by creating a new archive folder. And I could place that. Yeah, I'm not sure about that. Maybe I'll just place it here initially, at least. Make new folder. Project manager. Like this. Okay, so that. And then here I will choose backup to archive. I'm always using the Navipac full script. And then next. And then extra folders would then be, of course, the project folder on top of the standard folders. And that's this one here. Project folder. Okay to that. And then I can go to next. This is then on, off, 4. And finish. And now it is creating a backup in the form of an executable zip file that contains everything that I have right now. See, these are actually the NPD files that we've created. So now I've created a full backup that contains the software part. That is what the project manager does. It takes backup of settings in the CI Navipac folder. but I have also added the project folder. And I think that is the way this should be handled. As a matter of fact, here is my executable that I can then restore. If I do that, then I get a Navipac configuration that is identical to the configuration I had at the time I performed the project manager backup. So that is, of course, an important thing to convey to you guys. But the exercise, going back to the exercise, I'll send you the exercise notes, same as yesterday, in 5-10 minutes or so. Same procedure as tomorrow. And then you guys will send me your answers. And please be aware that if you send your answers after 4 o'clock, I'm not going to look at it until tomorrow. But it's okay to send it after 4 o'clock. No problem with that. Okay.
I have one question, please.
Yeah.
I have a problem deleting connection lines. I don't know why.
No, I
On
don't
the
know
data-
why either.
On the data mode.
Could you try to share your screen?
Okay. Can you see my screen?
I can see your screen, yes. Just select the connection line.
It's selected, but
Press delete on the keyboard.
I didn't get any response. Oh, okay. It works.
Now you do. Yeah.
It works.
I can see now that you have a problem. That's your string merger. The properties on your string merger. I did tell you. Click on the string merger.
Yes.
I need to see. Yeah, I need to remove the 3 in brackets. Otherwise, you get this error message constantly. Remove 3 in brackets.
Like this?
Yeah, and then the comma is fine. Just enter the comma again. And then right-click in the warning down there and choose remove. At the bottom, you have a warning. Right-click there.
At the bottom?
At bottom of the window. No? Can't you see the warning at the bottom there?
Okay. Yeah.
Right-click.
And
Clear all events. Clear all events.
Yeah.
Now you don't get any new warning. So remember to save your.
Okay.
Yeah. So now it's okay. File, save. Right. Okay, guys. That's it for today. And yeah, same procedure. But I'll hurry sending you the exercise notes. And then if not before, then we will meet tomorrow.
Okay then.
Thank you very much for now and goodbye.
Yeah.